So this hour, please take a look at this link, HuggingFace NLP course. Okay, so HuggingFace provide a very convenient tools and packages to help you to build your application with language model. So it has a neural language process course, and of course there are some other course provided by HuggingFace. If you're interested in different topics, for example, audio or deep learning, okay, or some other course, okay, you can take a look at them. And I would like to say something about our agenda right here. So as you can see that because the policy made by the university, so in this semester we have only 16 weeks, so we have 2 additional weeks. So right here, for the last week, which is the +1 week, so that in that day, okay, we don't have to you don't have to come to class, and we will not have live streaming as well. So you learned by yourself, okay? So I think the NLP course and the diffusion course is quite nice. So basically diffusion is right here, NLP is right here. So I strongly encourage everyone of you take a look at this diffusion and NLP course. But today we will go over some of the codes of the NLP course, because those codes are, you need to use this codes to write your homework, which is the this one, okay, language model attack, okay, which is this one. We will explain how you write this homework later, okay, later in this week, okay. So let's take a look at the HuggingFace, okay. So here's the introduction, but I think the important thing is right here, okay. 1.2 neutral language process, NLP, okay. You can see that it lists some of the NLP text, okay, and if you think your application is quite fit to those texts, again, you can try to use some built-in examples to try to modify them and to create your own application, okay. So first thing is classify whole sentence. Very similar to our previous example in TensorFlow and Keras, right? In that example, we use IMDb paragraph, okay, or review comment to perform a classification to see if the review comment is a positive comment or a negative comment, right? So it simply falls into this category, classifying whole sentence, okay, into different classes, okay. For example, right here, sentimental review, detecting if a mail is a spam, just like what we have done in our homework, okay. Determine if a sentence is grammatically correct or whether 2 sentences are logically related or not, right? So in this course, there will be some example to teach you how to perform this task, okay. So another category is classifying each word in a sentence, okay. For example, identify the grammar component of a sentence. A word is a noun or verb or the adjective or person or location or organization, okay. Third one is generating text content, for example, to auto-generate text. I think you have heard of ChatGPT, right? So it is a part of this. It is somehow very similar to this NLP text to generate the next word by referencing the word, the previous word, okay. Extracting an answer from text, okay. We will show you how it works. And this one is generating new sentence from the input text. For example, translating text into another language, Okay, so there are some those are important and commonly seen NLP tasks. Okay, but the challenge is that basically, if you want to do neural network, you have to convert your text-based input to numeric, right? And we show you how TensorFlow Keras to perform, right? It has a one-hot embedding, encoding, and it performs some kind of embedding, right, to output the vectors. Okay, but here we'd like to show how transformers can do. So if you are not if you are not that familiar with a transformer, you can take a look at this one. Okay, but for HuggingFace, it provides a very simple and useful functions. For example, just like what we did in the previous hour to classify review, right? So here, transformers, HuggingFace transformers provide a lot of pipelines. So one of the pipeline is sentimental analysis. So basically here, it will load some built-in language model, just as what we did in previous example, right? The previous example we use BERT, right? But it has certain built-in language model used by the pipeline function. Okay, so it created a classifier because sentimental analysis is a classifier, right? So there will be a classifier attached after the language model. So here we simply just test this sentence. I've been waiting for a HuggingFace course my whole life. So it will generate it is a positive sentence or it is a negative sentence, and its corresponding value will be right here. So that 3 lines did what we introduced last hour, right? We have to write dictionary, we have to use the preprocessor, we have to use the predefined BERT model and the classifier to create sentimental analysis task, right? But in HuggingFace, the transformer pipeline can simply just do so by using 3 simple lines. Okay, so we can pass several sentences by such in this one, such as these 2 examples. Okay, so the question is, how many different pipelines are predefined by the transformer pipeline function? So here is all the available pipelines. I strongly recommend you take a look at the pipelines pages so that you can understand how many different pipeline. Okay, for example, right here, fill mask. This pipeline is simply just, it can perform closed task. Okay, just as what we introduced in skipgram and Hsiao. Okay, so for example, translation. So it can input a text and output is translation. So it depends on what model you select. If you choose a model which can translate English to French, and this translation pipeline can translate English to French. Okay, text classification. It is an alias of sentimental analysis. Okay, so you can perform classification. So I strongly recommend you take a look at how many different pipelines right here and what is the definition of different pipeline, so that you can easily map what pipeline you should use to perform your own application. Okay, so let's take a look at some interesting and important pipeline. Okay, so the first one is zero-shot classification, and I think in your homework you should use this one. Okay, so for this specific pipeline, it's simply just, here is the input. This is a course about the transformers library. But zero-shot classification is a classification. You don't have to train the classifier. You simply just provide how many different classes you have. Okay, this one is education, politics, and business. So that task simply just, okay, here we have a sentence, and we can map this sentence to a high dimensional space, okay, by using certain built-in language model. Okay, and this built-in model will transform this sentence to a latent space. And here we have three different candidates: education, politics, and business. And these three different words can also be projected to the same high dimensional space. So it is quite easy. We can simply just use for example, cosine similarity to see this sentence is close to this concept or this concept or this concept. And as you can see, here is the score provided by this zero-shot classification pipeline. And we can see that this concept, education, is more close to, more similar to this sentence, because here is a course right here, which might be similar to the concept of education. The result, the score is 84%. Of course, this course score is calculated by some softmax function. Okay, so the sum of them will be 1.0. So this pipeline is quite useful because you don't need to fine-tune the model by using your training data. You simply just perform some kind of a similarity function. Of course, this similarity function is built in this zero-shot classification pipeline. Another is text generation. So the pipeline you use is text generation. It will load certain built-in language model. And after that, you can see that here is the text. So this text will be used as an input, and this pipeline will generate the next word, which is right here, which is understand. It is very similar to closed test, but you put the blank word at the end of your sentence. So in this case, this language model will output understand. So after it generates this word understand, and it will use the word, the sentence, which I mark right here as the input, and trying to output the next word, which is end. And after that, the model use this sentence to output use, and so on and so forth, so on and so forth. And we call this process is auto-regression. Okay, auto-regression. So that is how it works. Okay. So of course, different pipeline, they have different built-in language model, but you can also specify which language model you would like to use. So here we have a model hub right here. So you can see that there are several different models provided by people all around the world. Okay, so at the left-hand side, you can see that there are several different tasks. Okay, so for example, if you would like to perform text classification, so you click this tab, and as you can see that all those different models right here, they all support text classification. So basically, they have a language model, and after that language model, they have their own built-in classifier attached after their language model. Okay, so different people, they have different models. So you only need to copy this name, for example, right here. And after that, you simply just put it right here so that you can select which model you would like to use to perform text generation. For example, for text generation, you need to text generation. There will be some. Okay. Anyway, okay. To perform, so there will be different different models. Okay. So that is the result. So again, mask filling, which means closed test, and its name is fill mask. Okay, it's quite well. So it's quite nice. Basically, you use this special token mask. So this model will output, for example, top K equals 2 means it output the two most the two word in the dictionary, and their softmax value is the highest and the second highest one, which is mathematical and computational, and their softmax value is right here, so that you can do fill mask, which is a closed test. Okay, so here we've that is name entity recognition. So each word right here, okay, there will be output class output a class for each word. For example, Sullivan, it is person. Okay, HuggingFace is organization. Brooklyn is location, and that is softmax value. Okay, so question answering, and of course some model are trained for output some text to answer the question. So for example, the question is, where do I work? And the context is, my name is Sullivan and will work at HuggingFace in Brooklyn. So you have to provide the context and a question. So the model, the language model, will try to answer this question according to the context you provide. So the answer will be HuggingFace. And here's the softmax score value. So summarization, okay, we have a longer one, and here we can the language model can provide a short version of the text. Okay, translation, you have to select the correct model right here, and you can perform translation from some language to another language. Okay, so basically I strongly recommend you take a look at the different pipelines and try to figure out how to use them, and if it's possible, you can use them in your final project. Okay, so here's how transformer works, and we talked about all those things in last week, right? We talked about how closed text works. So basically the actual name is mask language modeling, which means closed text. Okay, in short, it is MLM. Okay, you simply just remove for example 50% of the word and try to perform self-supervised learning in your language model. Okay, and as you can see that there are some very big language model, so it has millions of parameters to be trained. And in HuggingFace, most of the time, some models are preferred. For example, DistalBERT, because it has a very nice performance, but it has relatively less parameters. Okay, so if you want to use some, for example, test classification or sentimental analysis, you can use DistalBERT, okay, as your model. Okay, we will talk about more detail about the transformer maybe next week. Okay, so currently you simply just know how know that we use the encoder as the BERT. Okay, so we skip these things. Okay, and so right here. So here, I'd like to show you the sentimental analysis, which is text a classification. Okay, you simply just do this pipeline sentimental analysis and provide several different sentences, and the output is value. So actually, its model, its internal structure is you need to have a tokenizer, which is the dictionary and how you divide your sentence into tokens, right? And so there will be raw text and there will be a pre-processing, and here's the output ID based on your dictionary, and your model will transform this one hot encoding to numeric vectors, and those vectors will further the proposed processing might be a very simple classifier, so they can map this value to prediction of the class. So here the two classes, right? Positive and negative. So that is the internal. But actually, you cannot change anything in this structure because those are built-in pipeline. So you can simply just use it. Okay, simply just use it. So right here, we can obtain the tokenizer by using this function. So that is the name of the model you use. Okay, you can simply just use this function to obtain this tokenizer. Okay, and you can tokenize this your example, right? So you can see that that is the one hot index of your sentences, and that is how the padding. Okay, so because this sentence is shorter, so here's the mask. Okay, so here again, in order to obtain your model, if you really want to obtain the model, you can use this auto model from pre-trained, and you simply just provide the name of your model. You can obtain your model, right? So you can input your sentence to this model, and this model will output its corresponding output. And as you can see that it will be 16 dimension, right? And as was mentioned before, the output of certain model and its output dimension is 16 by 768. So that is the size, and you can see that is the internal structure, right? Input model, the input, and first is an embedding and layers of a layer transformer, and we have the hidden states, and we have several different heads, right? So that is the output of the model. We will talk about this next week, okay, in more detail. So but basically, if you simply just want to use these models, you can simply just use pipeline. But you want to perform some other things, you can download the tokenizer and the models. So as you can see that you can log it the value and to output the corresponding log it value, and perform softmax so that you can understand it is a positive common or it's a negative common. Okay, so that is pipeline. So here we have a lot of models, and you can create your models as well. So basically you need to write the configuration. So in the configuration, you can design your bird model with different hidden neurons, intermediate size, the length of your maxima input size, how many different heads, okay, multi heads right here, how many different layers you do. So basically you can use the configuration to design different variation of BERT, but I don't recommend you do so because BERT Google has already create a lot of different BERT configurations, but you can simply just name the model and download the pre-trained model. Okay, you don't have to do so by yourself. Okay. So the tokenizer, okay, as we mentioned before, one thing I like to talk about is that basically the tokenizer used by BERT is a little bit different. They do not simply just tokenize, split the sentence by white space and punctuation. Basically, we mentioned it before, it will split the entire sentence to different word pieces. So as you can see that the word tokenization will be split into two different tokens. The first one is token. The other one is ization. Because in BERT's dictionary, they don't have tokenization, this word. But it has token and ization. And it will make the dictionary more efficient because there's a lot of word ends with ization, right? So that makes your dictionary more efficient. And after that, take a look at this one. This one. If there are some word not in the BERT dictionary, that they may be split some words by using English characters. So again, English characters are in the BERT dictionary. So if BERT trying to tokenize a word it has never seen before, it may divide them into individual English character as the token. So that is why BERT is more efficiently, because you simply just don't need to make your own dictionary, because it has all the English characters in the dictionary. So you don't have to redefine the dictionary by yourself. Okay, so that is what I would like to talk. And after that, so we'll skip this one. After that, what I could show you an interesting thing, which is I wrote here. This one. 7-3, which is right 7 here and 3, okay? So basically, in previous example, we simply just download the tokenizer and the model, and you can perform whatever you like. Or if your task is simple enough, so you can use pipeline to perform your task. But what if you would like to train the model, language model? For example, as we mentioned, BERT, when training BERT, they use all the Wikipedia articles and some books to train the BERT model by using MLM, or we say closed test, or we say field mask, right? But what if you would like to fine-tune your language model by MLM, which means you believe the language model can obtain some additional knowledge by the document by the corpus you provide. So you like to train the model again, trying to make the model obtain additional knowledge, and here is how you do it by using HuggingFace. Okay, so that here again, you can select one of the model as your base model. And after that, okay, in this example, it used this bird based on case as your base model. So here's the base model, and you simply just load it. So here's the model. Okay, so after that, you can see that there are some useful function. For example, how many different parameters in this model, and it is 67 million. Okay, so here for this base model, if you perform close task, okay, so you simply just feed this sentence into this model, and so that okay, there's one thing you need to know is that in HuggingFace right here, there's always two buttons right here. So it specifies what package you want to use. You want to use TensorFlow or you want to use PyTorch. Okay, so because in our class most of the time we use TensorFlow, so simply you have to click this one. Okay, and you can open this example by using Colab by clicking this tab. Okay, so let's go back to the it's right here. So after you load this one, okay, you can perform summary. So here's the summary of your predefined model. Okay, so if you input this text into your model, so ideally so here, as you can see, that you put them into your model. So you simply just copy this line. Okay, so after that, after we obtain this softmax of all the word in dictionary, we simply just sort them and select the top 5 word. Okay, so as you can see that the result is it is a good deal, it is a good success, adventure, idea, and then fit. So because the base model, they learn English by using Wikipedia's article. So basically those word, okay, is a very commonly used word. Okay, so after that, we wish the base model can learn some movie knowledges from IMDb dataset, which is the dataset we used before, right? So here's the example. Okay, we load the IMDb result, and as you can see here, okay, here we have training data, we have testing data, we have unsupervised data, and here's the as we mentioned, half of the data will be the training data, half the data will be the testing data. If you simply just ignore the training and the testing, okay, in total there will be 50,000. And for each data, there will be a text and a label. So that is data structure. Okay, so if we simply just random select some example from the training data, and you can see that here's the text and here's the label. Okay, so we believe that there are some movie knowledge in those review comments. So we like to train the base model by using this text. So again, right here, and as you can see that you can perform tokenization by yourself, and as you can see that you can simply just use the built-in dictionary, which is provided by the tokenizer right here. Okay, tokenizer right here. So basically you simply just apply the tokenizer to the IMDb dataset. So for example, all the text right here will be convert to an index, right? The integer index. So Again, so we have the attention max, we have the input text, and the word IDs. So you can simply just output them. Okay, take a look at them. Okay. So after that, here, okay, reveal 0, the length is 200, and you can simply just output its input ID. So it's right here. Since the bird model only the bird model we select only accept the length is 128, so you simply need to truncate the data because the IMDb dataset is downloaded from the network, so it is not pre-processed. So you have to pre-process it by yourself. Okay, so simply just take a look at this part. Okay, so after that, after this pre-processing, okay, so you simply just use this built-in function map to perform this function on the dataset. Okay, so after that, you can see that here is the example. Okay, so here's the labels, and then you simply just copy these cells, right? You have a tokenizer and you want to perform MLM. So the probability is that 50% of the word in these sentences will be marked as mask. Okay, so here is the result. Okay, here is the training sample. Here we have a lot of mask right here. Okay, 50%. So after that, okay, again, you simply just copy these functions, okay, and take a look at the implementation. Okay, so it teaches you how to randomly mask word. Okay, so here we have the mask word. Okay, so after that, we will try to perform split. Okay, so that we have a training data set, we have a testing data set. Okay, so right here. So after that, if you for example, this netbook login is a HuggingFace library. Okay, so that means because some code in this this file, they require you to upload your model to HuggingFace hub. But actually, when you do your homework or project, you don't have to do so. So you simply just ignore all the codes related to HuggingFace hub. So we skip this part. Okay. So after that, we have TensorFlow dataset, training and testing. Most of the time, you don't have to change all the things. Okay. So after that, again, we have optimizer, we have learning rate, and we have compile, and we have some callback function. Okay, and here is the model. Okay, so after that, we simply just apply fit, which is right here, and then they will use the movie command to train your base model again and again. So after that, you have this model, right? So you can perform evaluation, and you can see that here we have this word perplexity. Okay, perplexity is that when we perform closed test. So let's take some, for example, right here. If we perform a test right here, and in this, when they perform prediction of this word, okay, there should be a softmax value for every word in the dictionary, right? So we simply just select the top one word, which has the maximum softmax value, right? So right here, the perplexity means how surprised this word will be selected. Because if the model output a word and its softmax value is 99%. So that means the model knows how to perform close test on this specific sentence, right? But what if the model output word which its softmax value is only 20%, and the other word, the second highest softmax word is 20%, 19%, 80%, and 20%. So that means this model has a very low confidence how to do close test in this specific sentence. So that is the how perplexity means. So if this number is large, that means the uncertainty of this model to perform close test is higher. Okay, so that is the model. So after you perform fit by using the movie comments, and that means your model gains a lot of movie analogies. So after that, you perform evaluation again, and you can see that perplexity decrease. That means the uncertainty of this model to perform close test, the uncertainty decrease. So that means it gains lots of knowledge about movie. So that perplexity decreased. So that is. So after that, you can use your model by using in pipeline as well. Okay, so after that, you can see that right here. Now, if you perform MLM, and you can see that that is a great movie. So all the word which is are all related to movies, films, right? Because those words are frequently used in the common, and you train your model by using these comments. So that is okay. So you have to take some time to carefully take a look at this collab file and try to run it by using movie length, and you have to modify this one as your homework aid. Okay. We stop right here. We will talk about how do you write your homework aid and your project next hour, and we'll talk about packet. Okay, in next hour.